Hello viewers, welcome to Unacademy YouTube channel. Myself R.Vetrivel, Unacademy plus physics educator. Welcome all the viewers to the India's topmost #1 online platform for teaching and coaching. Today we are going to discuss the concept of Kirchoff law and electric power related problem. Let us begin today's session. Before Unacademy plus subscription, it is the best plan for Karnataka CET 2021 aspirant. Right? It is an affordable price and complete syllabus preparation will be taken care. You will get daily practice test, full length mock test, etc. Everything with analysis. For single subscription, unlimited access you can get 24/7. Use my code Vetrivel Ramanathan to subscribe Unacademy Plus course. Let us move today's session. Electric power. Right? Electric power. Good afternoon, all the viewers. Rukaya, Nilanshu. Very good evening. Good afternoon, all. Yes, today's session, it's the electric power. We all know electric power is rate of doing electric work, W by T. Work done we can write VIT, that is V into I, we know. So SI unit of electric power watt or joule per second, work by time. Right, this we know. The biggest unit of electric power is kilowatt and megawatt. This is the biggest unit of electric power. Kilowatt is nothing but 1 kilowatt is 1000 watt and 1 megawatt is 10 power 6 watt. The commercial unit of electrical energy is horsepower. See that? Commercial unit of power, horsepower. Yesterday we discussed commercial unit of electrical energy is kilowatt hour. But here power unit watt, bigger unit kilowatt and megawatt. Kilo into 1000, this is 10 power 6. Commercial unit of power is horsepower. 1 horsepower 746 watt. Expression for electric power in terms of current and resistance. We know from Ohm's law V equal to IR. So substitute P, we will get I square R. P equal to I square R. Right. So electric power in terms of V and R, potential and resistance will be, we know that I equal V by R. So power formula, if we substitute, power equal to work done by time, right? Work done equal V into Q, that is T. V into Q is IT by T. T cancel, that is why you will get V into I, power. So there you substitute V into I, V equal to IR, substitute, you will get I square R. Right? From that I equal to V by R, substitute, we will get V square by R. So power formula we all know. W by T, that is V into I, that is P equal to I square R, that is equal to V square by R. These are all power related formulas we know. Yes, let us move to the next one. Resistance of filament of the bulb. Right? Resistance, we know power equal to V into I. Right? Just now we discussed power equal to V square by R. In that R you take it. V square by R. R equal to V square by P. So here potential is constant. Then R is inversely proportional to power. See that. More power, less resistance. If the resistance is less, more current will flow through. So see here, you are given 100 watt and 230 volt bulb. Another one bulb is 60 watt, 230 volt potential. Right? Now here the 100 watt bulb will have less resistance compared to the top 60 watt bulb. We know the relation. See, two bulb is given 100 watt, 230 volt, another is 60 watt, 230 volt. See here, resistance is inversely proportional to power. So, power is more, resistance will be less. See here, 100 watt. So, the 100 watt bulb will have less resistance because power is more, resistance will be less. So, resistance less mean what happen? Current will be more. Keep in mind. So 100 watt bulb will have less resistance mean it will allow more current. So allowable current I equal we know P equal to V into I. From that I equal P by V. I proportional to P directly, right? More current, more power. V is constant. So in this above case, 100 watt bulb draws more current because we know power is inversely proportional to resistance. More power, less resistance. Less resistance means current it will receive more. That's why 100 watt bulb will receive more current. Next one. If suppose I am connecting the two bulbs in series. So the bulbs connected in series. Bulb connected in series, current will remain same. Series connection, same current can flow through. Right? Okay. Now, good evening, Amina. Right? Yes. Mohammed Shoaib, Paul. If the two bulbs are connected in series, same current can flow through. That is given. In series bulb with the low wattage rating glows brighter than higher wattage bulb. Keep in mind, low voltage bulb will glow brighter. Just now we discussed, see here, 100 watt, 230 volt, 100 watt bulb, 60 watt bulb. In that, we know power is inversely proportional to resistance. Right? So resistance less mean power will be more. So 100 watt bulb will draw more current. So see here, now the bulb connected in series, same current will flow through. Then low wattage will glow brighter, high wattage rated. When compared to high voltage bulb, the low wattage bulb will glow brighter. Keep in mind, reason we know power equal V square by R. Here the two bulbs are connected in series. First bulb resistance R1, second bulb resistance R2. Then series means equivalent resistance will be R1 plus R2. Both bulb resistance, first bulb, second bulb, two bulbs are connected in series. So equivalent resistance, effective resistance will be R1 plus R2, series connection. Then we know here see P equal V square by R, R equal V square by P. See there, here relation. So R take it up, P bring it down. R1 equal V square by P1, R2 equal V square by P2. Then 1 by P equal 1 by P1 plus 1 by P2. Right? See here. 1 by when the two bulbs are connected in series, their effective power will be reciprocal of total power equal sum of the reciprocal of individual power of the bulb. When the two bulbs connected in series, 1 by P equal 1 by P1 plus 1 by P2. Low wattage bulb will glow brighter. If we take 60 watt and 120 watt, low wattage 60 watt bulb will glow more brighter. In parallel connection, see that, good evening Shama. In parallel connection, if the two bulbs I am connecting in parallel, bulb 1, right here, bulb 2, both are connected in side by side parallel, two bulbs. So in parallel, high wattage bulb glows brighter. In series connection, low wattage bulb will glow brighter. In parallel connection, high wattage bulb glow brighter than less wattage bulb. Right, now what is the total power consumed? We know relation, power P equal V square by R. So 1 by R equal effective resistance of these two bulbs. First bulb resistance R1, second bulb resistance R2. So 1 by R1 plus 1 by R2. 1 by R here, 1 by R is P. So 1 by R1 P1, 1 by R2 P2. So when two bulbs connected in parallel, the total power will be sum of these two power individual P1 plus P2. In series mean it will be reciprocal. See 1 by P equal 1 by P1 plus 1 by P2. In parallel, effective power will be sum of the two. This you need to remember, very useful. In series grouping of bulbs, if number of bulbs I am connecting in series, imagine if number of bulbs connected in series grouping of bulb of greater wattage gives less bright, will have less resistance. See here, P all see wattage, right? More wattage mean less power, more wattage less potential, more wattage less resistance, right? Inversely proportional. This keep in mind in case of grouping of bulbs in series. In series connection, number of bulbs connected end on end. One bulb get fused mean other all will not work since all connected in series. If the one bulb fuse, other bulb all will be out, will not be work. In parallel connection, suppose number of bulb I connected in side by side parallelly, then bulb having greater wattage will give more bright light. Right? See, keep in mind, this relation you need to remember now. 1 by R, if the resistance more, power will be less. Or if the resistance less, power will be more. Resistance less, current will be more. Resistance less, wattage will be more. So in parallel connection, one bulb get fused, other bulb will not get affected. Only this particular bulb will be get fused, remaining all will work. That is why always in house wiring, parallel connection is preferred. If the one room goes fused, other all will be safe. So this idea keep in mind. Let us move to next one. Daily practice test is going on in Unacademy for KCET. Right? Attempt the test for free. Right? It's already going on. Enroll now. Right? Now come to the first question. Yes. See here, a lamp of 100 watt power, 100 watt bulb works on 220 volt. What is the resistance and current capacity? What is it, resistance and current capacity? Yes, you can calculate and tell me now. Yes, what is the Nilanshu? Now tell me. Lamp of 100 watt works at 220 volt. What is the resistance? What is the current capacity? Relation you see. PV given. What is the current? Right? We know power equal V into I. Remember, from that I find out current equal P by V. That's all. Both is given 100 by 220. How much? You will get 0.455 ampere. Current over. Now resistance find out. Right? Resistance. We know that formula. Power. Yes. Very good. Resistance. Good. Good, Nilanshu. It is. We know that power equal to V square by R. That's it. From that find out R equal V square by P. V square, it is given already. 220. Yes, Nilanshu, correct. 220 square. 220 into 220 square by power is given 100. That's it. You will get 484 ohm. Yes, correct, man. Right? Yes, Shama. Good. Now, B square 220 into 220 by 100, you will get 484. So, answer keep in mind, current 0.455 ampere, resistance 484 ohm is the correct answer. Let us go to the next one. See here, a 100-watt bulb power voltage is given. It will work under 220 volt bulb. Is connected to 110 volt source. Calculate the power consumed by the bulb. See, originally when you purchase the bulb, 100-watt bulb, it will be written on the 220V. That means it works under 220V. But you are connecting to 110 volt. See, its capacity of the power of the bulb 100 watt, 220 volt. You are connected to 110 volt source. Then how much power consumed by the bulb? Right? How much power consumed by the bulb? Here, power of the bulb is given 100 watt. Right? What is the operating voltage is given? Operating voltage, it is mentioned, see. Operating voltage, the power will operate under the voltage 220 volt. But here using this, what is the resistance? Find out. We know power equal V square by R. From that resistance equals V square by P. Find out first resistance. V square 220 whole square by P. Yes, Nilanshu, correct. By power. Power will be here. How much is given? 100 watt. So 100. You will get here 484 resistance you got. Now you are connecting what is the actual operating voltage, right? Operating voltage starting is given 220, you got resistance. Now the bulb is connected to 110 volt. Now actual operating voltage will be 110. This is V dash. Now what is the power consumed by the bulb? Use it. New power consumed by the bulb. V dash. This one new voltage. V square by R. That's it. 110 whole square by resistance. How much resistance is offer now? 484. Simplify. You will get 25 watt. So correct, Nilanshu. It is 25 watt power. Calculate the power consumed by the bulb. This is. Now let us move to the next one. A 100 watt and a 500 watt. See, two bulb. First bulb power 100 watt. Second bulb power 500 watt are joined in series and connected to the main. Which bulb will glow brighter? Right concept I showed you. Which bulb will glow brighter? Right? Yes, tell me now which bulb will glow brighter? Both bulbs are connected in series. So suppose R1, R2 be the resistance of the two bulbs. If each bulb are connected separately to the main, each bulb are connected separately to the main, then what happen? First bulb P1 equal to V square by R1, first bulb. P2 second bulb V square by R2. Now P1 by P2 equal, how it is P and R inversely proportional. So R2 by R1. Yes man, correct. This concept I will show them and will ensure. Correct. So here R1 by R2 equal, right, R1 by R2 equal P2 by P1. See that? Inversely proportional. So P2 how much is given? 500 by P1 100. So you will get P2 by P1 5. If the two bulbs are in series to the main, the two bulbs are connected in series to the main. So current flowing them will be same. Series connection current is same. Let P1 and P2 be the power dissipated by the two bulbs. Then we know that formula, power P equal to I square R. First bulb P1 equal to I square R1. Right? Similarly P2 equal I square R2. That's it. Now P1 by P2 equal, here P1 R1, P2 R2, here directly proportional. So P1 by P2 equal R1 by R2. What is R1 by R2? Already we know R1 by R2 is 5. So P1 equal to 5 times P2. So which is power less? 100 watt. 100 watt bulb dissipate more power, it will glow more brighter, right? Whenever the two bulbs we are connecting in series, which bulb has the less wattage will brightly glow. That only series combination, I told you starting itself, right? The bulb which has lesser wattage will glow brighter. So 100 watt bulb will glow brighter. 100 wattage bulb will glow brighter is the correct answer. Yes, let us go for next one. Here it is. Now come to Kirchoff laws based on. Clear? Find the circuit shown in figure. The potential difference between point A and B is 16 volt. That means VA potential at point A VA, potential at point B VB. So potential difference between A and B means VA minus VB, that is equal to 16 volt. That's only given. Find the current passing through 2 ohm resistor here. So what to do? Potential difference between A and B is given 16. That only I showed you. VA minus VB. Potential difference. VA minus VB equals 16. It is given. Now we need to find what is the current passing through 2 ohm. Right? Yes, yes. You are from Tokyo, Sensei, right? Anyway, welcome. Good. Now, see here. One equation it is given potential difference, right? So another equation we have to go for closed loop. In this closed loop, suppose P, Q, R, yes, this is the closed loop. Potential difference VA minus VB is given clearly. VA minus VB equal to 16. From here you start, right? From VA, from here you can start it, you will get it. Now see, same direction, minus 4 I1, it will come here, right? It will go down, see, I1 plus I2, because from this battery, see, I2 is coming, both combinedly comes down, I1 plus I2. So minus 2 into I1 plus I2, use the sign convention. Will go here. Now I am root from A to P, P to Q, Q to R, R to S, S to B. I am going for this VA minus VB minus, here you see, increase in potential. This one increase in potential plus 3, same direction, minus 4I1, right? It is equal to 16. So VA minus VB I got. This you simplify, you will get one equation. Next is in a closed loop, PQRS. It is a closed loop. In this closed loop, apply sign convention now. Apply the Kirchoff second law, Kirchoff voltage law you can apply now. Right? Here when you apply Kirchoff second law, see here, it is increasing potential. Start from here or from here you start P to Q, Q to R, same direction current is flowing. So, in a closed loop, P, Q, R, S, P, start from P, minus 2 into potential, right? 2 into what is the current? I1 plus I2, I1 plus I2 goes up and S to this direction. Now, minus same direction, minus 1 into I2. So I2 potential, see there in the cell, negative to positive, increase in potential. So plus 9 is equal to 0. That's it. Now you will get, this is second equation. First one, you simplify this. Minus 4I1 minus 2I1 plus minus 2I2, that minus 2 multiply inside, plus 3 minus 4I1 is equal to 16. This you simplify, right? This 3 take equal that side. 16 minus 3. You simplify, you will get 10I1 plus 2I2 is equal to 13. Equation 1 you will get. This you multiply inside. Closed loop. First potential difference we did. Now closed loop, 2 into I1 minus 2I2 minus I2 plus 9 is equal to 0. Now you will get 2I1 minus 3I2, right? All minus change the sign, plus 3I2 is equal to 9. This is equation 2. Now you got the two equation. You can simplify, right? Solving equation 1 and 2. Both equation you solve it, you will get I1 1.5 nearly. I2 you will get 2 ampere, you will get. Solving both equations, try. You will get I1 1.5, I2, right, 2 ampere. Then what is the current through 2 ampere? Yes, Nilanshu, correct. Current through the 2 ampere, I equal to I1 plus I2. I1 1.5 plus 2, total 3.5 ampere is the answer. Current through 2 ohm will be sum of I1 plus I2. You will get 3.5 is the correct answer. Yes, Nilanshu. 3.5. Yes, good. Let us move to next one. See here, right? The given 4-terminal network is a part of larger circuit. Larger circuit. The point A, B, C are at the same potential. Keep in mind, right? The point A, B, C all same potential. The potential difference between any one of A, B, C, D is 40. Any one. Right? Find the potential difference between A and O. See that clearly. Find the potential between A and O. Right? So, I will take now potential of A, B, C as 40. See that potential of A, B, C all I am taking as 40. This point. Because they are given A, B, C are same potential. So A, B, C I am taking as potential 40. Right? Potential of D I am taking as 0. 0 volt. right? So potential at O, the junction I am taking as VO. That's it. Question is, find the potential difference between A and O. Have you tried now? Kirchoff law apply at the junction rule first. You see that according to Kirchoff current law, first law, at junction O. Tell me now, at junction O, some of the current entering. I can say, right? I will show you. This is current I1. This is current I2. This is current I3, right? And this is current I4, arrow mark C. So current I1 plus I2 plus I3 is equal to I4, right? It's moving away. Now use this. Now I1 here, what is the potential? I1, we know I equal to B into, we know, right? I equals, now what is the potential between B and O? Current, use it man, current equal to V by R formula, use it. We know at junction O, I1 coming towards, I2, I3 coming towards are all plus equal to I4 moving away. Now I equal V by R. Apply now the same V by R here. First one A to O. A to O potential difference here, higher potential minus lower potential. See that at point A 40, at O VO already I said. So V by R, higher minus lower by R equal. Now come to B and O, higher minus lower by R. Next here C and O, right? Add all, because I1 plus I2 plus I3, I1 plus I2 plus I3 here 40 minus V naught by R. We are using V by R rules. See here, we got I1 plus I2 plus I3 equal to I4 according to junction rule. I1 is V by R. V by R means that's only potential difference. 40 minus lower, this end what? V naught. 40 minus V naught by R plus I2 plus I3 equal I4. What is I4 potential difference? At D0. Here V naught. So V naught higher minus 0 by R. That's it. Now simplify this all. Left hand side. Left hand side R. Top add all. 40 minus V naught plus 40 minus V naught plus 40 minus V naught. 120 minus 3 V naught. That is equal V naught by R. That's it. So simplify now. From this R cancel. 120 equals minus 3V naught plus 3V naught, 4V naught. So V naught equal 30 volt. Now potential at O we got 30 volt here. Now I got potential at O 30 volt. We want to find potential difference between AO. At A what is 40, right? At A potential is already 40. Now at O potential is 30. Now what is the potential difference between A and O? 40 minus 30, 10. So potential difference between, right, VA minus VO. 40 minus 30, 10 volt is the correct answer. So potential difference will be 10 volt. Now find the potential difference between M and N here. What is the potential difference between M and N? For that your understanding purpose, I made as a closed loop. Now dotted line I joined. Potential difference between M and N we need to find. So let us have a closed circuit by joining M and N by the dotted line. Now let potential at M Vm. Let potential at N Vn. So now use in clockwise direction, apply Kirchoff second law. So apply Kirchoff voltage law, potential difference between M and N. Vm minus Vn, right? Minus, now start, right? Minus 4, where start from here, Vm minus Vn, apply the Kirchoff voltage law, same direction current. So what we'll see here, minus 0.4 into 6 VIR, negative sign. Here increasing potential, plus 6, again same direction, product of, right, current into what is the current? Same current only flowing through, right? 0.4, right? Same current only will come here also. So minus 0.4 into 2, product of potential, current into resistance. Again here increase in potential. So plus 4, that's it. That is equal 0. That's all. You simplify this, right? You will get Vm minus Vn equal to 6 volt. You will get answer. Simplify this. Yes, Nilanshu, correct. Right, I showed you. Just Mn as a closed loop I have taken. Apply the Kirchoff second law. Apply the sign convention. Make equal to 0. Vm minus Vn is nothing but 6 volt you will get. So 6 volt potential difference between Vm, Vn is the correct answer. Right? Yes. Daily practice test is going on in Unacademy. So you can attempt the test for free. Now see that. Find the current. Right? Figure below shows the current in part of the current I is here. Here what is the current I? So very simple dear, all see here this junction, apply the junction rule. Which are the current entering is positive, right? Which are the current leaving away is negative. See here 2 ampere coming towards. So that 4 ampere current will flow here, this direction. Right? Keep in mind. 2 ampere coming towards the junction. 2 plus 2, 4. The 4 is leaving away now. Now this junction come. This is P. Now this junction come Q. 4 ampere current is coming towards. But 1 ampere is leaving away. So here 4 minus 1. 3 ampere will come at junction. Now 4 ampere is coming. 2 plus 2, 4 here. This 4, here 1 is leaving away. So 4 minus 1, 3 will come here. Now again in this 3, 1.3 leaving away. So here what is the current? 3 minus 1.3. Here 3 is coming towards this junction. Right? Understand? So 1.3 moving away. 3 minus 1.3. How much? Yes. You can. Hey, Nilanshu, properly. Not 0.7. 3 minus 1.3. It is 1.7. So what is the current coming out finally? Very simple, man. Right? Yes. Shama and right. All see 2 coming towards. So output will be 2 plus 2, 4 current will come out. Here 4, 1 is moving away. 4 minus 1, 3. Then 3 minus 1.3 remaining will come out. So 1.7 is the right answer. Now what is the current in the circuit? See that. What is the current in the circuit? That's only question. Right. So see that now. Option C, Nilanshu, try quickly. The current in the given circuit is, see here, A and B is given. What is the current in the given circuit? Right? Yes. Apply Kirchoff voltage law in this closed loop. See that I will start from here. Same direction. Minus 10 into current, say I. Right? So it is goes increasing. Plus 5. Rise in potential. Again come this way. Same direction. Minus 20 into I. Again lower in fall in potential, positive to negative, fall in potential. So minus 2 equal to 0. That's it. So 20, 10 minus 30i equal, right? 5 minus 2, 3. That 3 take that side, right? It will be minus 3. So minus minus cancel, I equal, you will get 0.1 ampere. Yes, option A is the correct one. Consider 4 circuit shown in figure. In which circuit power dissipated is more? Which circuit power dissipated will be more? We know power equal to V square by R, right? So for power to be maximum means, see that P and R, how it is related? P should be maximum. See, consider 4 circuit, in which circuit power dissipated is greatest, maximum. Power maximum mean resistance should be minimum, inversely proportional. You calculate resistance all this. You calculate here 2 resistance series, it's a parallel. Here 2 series, here 2 parallel, and with this series, here 2 will be parallel. You calculate which resistance, which circuit resistance is less, that will be more. So option A, if you calculate resistance for all, these two are connected in parallel, so resistance will be less. So resistance less means power will be more. So first circuit is the answer. Yes, two resistors, right? 6 ohm and 9 ohm are connected in series to 120 volt. The power consumed by 6 ohm. How much power consumed by 6 ohm? See that we know current equal to V by R. What is the voltage given? 120 volt. By what is the total resistance? 2 are connected in series. Series means 6 plus 9, because total resistance will be add both series connection. So 120 by 6 plus 9, 15. You will get 8. Current is 8 ampere. Now what is the power consumed in 6 ohm resistor? Right, P equal I square R. That's all. Resistor is given. Current we know. Current is 8 square into R is 6 ohm. That's it. 64 into 6. You will get 384 watt. 384 watt. Option 1 is correct. Right? Yes, option 1 is correct one. The power consumed. Potential difference between point A and B. What is the potential difference between point A and B? Apply the Kirchoff law. You assume like a closed loop, right? Assume like a closed loop, right? Potential at A, VA, start now. Apply Kirchoff voltage law. Current is same direction. See here, battery, the cell is higher to lower. So decrease in potential. So minus 2. Right? Again, same direction current. I. Current is how much? 1 ampere is flowing. 1 ampere resistance, same direction. So minus 2 into 1. Again, rise in potential. Plus 5. Again, current 1 ampere is flowing, same direction. Minus 1 into 1. Right? What is the potential at B? Minus VB equal to 0. That's it. Now, VA minus VB. Potential difference between A and B means VA minus VB equal. Take this all other side. 2 plus 2 minus 5 minus 1. Minus of mine all take that side. Right? Plus 1. You will get 4 minus 5 plus 1, that is 0. So option 1 is correct. It is 0 volt. Yes, Nilanshu, correct. 0 volt. Then come to the last one. Find the current in the given loop. This is closed circuit. You take the loop A, B, C, A. right? Apply Kirchoff voltage law. Apply now. Start from A, this direction, right? Starting from A, see that rise in potential, right? There is a rise in potential. So 5, see that starting from A, this route, rising potential minus same direction, current and resistance. So change in potential 5I, next we come to here, minus I, 1 into I, 1I. See that there is a decrease in potential. So minus 3, right? Again here there is a rise in potential, plus 6, current I is moving same direction, minus 3I equal to 0. Apply the Kirchoff voltage law, that's it. Now 5 plus 6, right? 5 plus 6 minus 3. 5 minus 3, 2. 6 plus 2, 8. Minus 5I minus I, 6I. Minus 3 minus 9I equal to 0. That's it. So 9I equal to 8. I equal to 8 by 9 ampere. So option 2 is the correct one. Just you need to apply Kirchoff voltage law, properly sign convention, you can find easily, right? So that's the end of today's session, right? So Unacademy is the #1 online platform coaching in India. So use my code VETRILIVE to subscribe Unacademy, so you can learn for all the competitive examination from the top lecturers of Karnataka PCMB. If one single subscription, you can able to watch all the topic, all the subject PCMB. It will be very useful for you. So we will meet you tomorrow or next day in the next Unacademy YouTube session with another important concept of moving charges and magnetism. So the viewers, all Nilanshu and Suman and Rukaya, Sadaf, right, and Sansui, right, and Namrata Gowda, Shama, right, Amina, Muhammad Swaib, right, all the viewers, thank you for watching. We will meet you in the next YouTube session. Till then, myself Vetrivel, Unacademy plus physics educator, signing up from you all. Have a nice day. Thank you.